Pretty well. Thanks for asking. And Alexander, what have you done today?
Um, I went to uh, extra classes. I mean, to my teacher, and of course I took one class with him. And it was about their articles that is very difficult uh, um, theme for me. But now I'm getting better at this, and it was the best thing that I've done today.
Okay, so learning about articles. Cool. Uh, yeah, that's great. It's always better to get like those basic grammar functions down. Um, all right. And Deanna, welcome back. Deanna, how's it going?
Hi again.
Hey, how are you?
Pretty good.
Okay, good to hear. And Deanna, what are you going to do for the rest of the day?
Well, I'm going to read to continue with my book, a leadership book that I told you before.
Mm-hmm.
Also, I will do some job applications. And no more than that, maybe some exercise.
Okay, do a little bit of exercise. Cool.
Yeah.
All right. And Mauricio, welcome to class. Mauricio, how are you?
Good, and you?
Doing really well. Thank you for asking. Mauricio, I don't think I've had you in class. Where are you from?
I'm from Brazil.
Okay. Uh, and what do you like to do for fun? What do you do in your free time?
Oh, I like to play tennis and read the books, but uh, actually play tennis.
Nice. I like tennis. Tennis is fun.
Uh,
All right. And do you have a favorite tennis player?
yeah, Federer or Nadal, but uh,
Yeah.
maybe Federer.
Yeah. Federer is cool.
Do you
Nadal's, I
play?
mean, they're both amazing.
Do you play tennis?
Yeah, I used to play a lot more tennis than I play now. Uh,
Mm,
there's not much tennis in Central America, is what I found. But uh, yeah. Anyways, cool. It's good to meet you again, Mauricio.
thank you.
And let's get started with today's class about math and maybe get it back up. Perfect. And let's start with Alexander. Can you read today's title and next couple lines?
Yeah, okay. Uh, Math. Today we might do some math problems, and we will talk about math
Good. Alexander, when was the last time you did math?
every day. Today, for example, because um, I study engineering at the university, and it needs to solve some equations every day to get better. I mean, to get better understanding,
Get a better understanding.
and better.
Okay, nice. And good. Maybe, Alexander, can you ask Diana the next question?
All right. I'm sorry, Tiana. Do you like math? Why or why not?
Mm, if I like maths, yes, I like maths. I think maths are in in all sense. Uh, they are very important not only in finance, but also about the logic that you speak or the things that you do every day. So maths are inside in everything that you do during the day.
Okay. I missed a lot of what you said when Audie came in. It just slowed down. Can you repeat this part?
Which one?
The highlighted part?
I cannot see the highlighted.
Really? Can you see the screen?
Yes. Now, yes.
Okay, so just right at the beginning. So I think math, something, and then you said they are.
They are
So pretty
very,
much right after you said go
yes,
ahead.
like math, but also about the logic that you speak or the things that you do every day.
Yeah, I just didn't. There was a lot that I didn't hear.
Ah, okay. Um, I say that I like maths because they are implicit in everything that you do.
It is.
It is.
Listen to everything that you do. Okay, maybe it's in the logic that you speak and the things that you do every day. All right. And Diana, can you ask Laura the next question?
Okay. What is your favorite or less favorite type of math? Algebra, geometry, calculus?
Well, it's a long time since I don't. Since I'm not in touch with maths. But when I was at school, I usually practice calculus, and I had a job that involved some kind of calculus because I was in a department with a lot of bills and things like this, and I have to use calculus. But um,
Okay. Well, it's been a long time since I've done math, maybe, or been
yes,
involved in math. When I was in school, I usually practiced calculus, and I had a job that involved some kind of calculus because it was an apartment. A lot of bills, and I had to use calculus. All right, that's good. Um, and does anybody have any questions here? All right, let's go to the next page. And let's have Mauricio. Can you read the title and the words?
Vocabulary, plus or minus, times, divided by, problem, percent, numerator, denominator, fractions, decimal, calculate, exponent, exponential.
Okay, really nicely done. Go with exponent and exponential. Let's look at percent.
Percent,
Good. And then numerator
numerator,
and denominator.
denominator,
Calculate.
calculate,
Yeah, calculate.
calculate.
Yeah, nice job. Okay, and does anybody have any questions about any of these words?
What is the examples of numerator and denominator?
Okay, and who knows what the numerator and denominator are?
It's like they're up and down.
Yeah, so over. I don't really, that's just a random number. So the top number, maybe we can do that, is the numerator, and the bottom number is the denominator. Does that make sense?
Oh, yeah. Yeah, I don't know in my language too.
Okay, so yeah, the
In my
numerator
native
is
language, I don't know. The top number, okay.
in a fraction.
Ah,
Does that make sense?
yes.
You can say like 2a. Yeah, so numerator and denominator. Any other questions here? Okay. Mauricio, can you use exponential in a sentence?
Oh, exponential.
Exponential.
I don't know, maybe 2 exponential 2 is equal 4.
That's a little bit different. We might say 2 to the second power equals 4. That's a little bit different. It's still talking about exponents, but yeah, it changes around a little bit. Does anybody know how we would put exponential in a sentence? Any ideas?
It is like an upper number.
Yeah.
Two.
So it's kind of describes an upper number.
Yeah.
This is an exponent, the second 2, or even if we do so annoying. So the 2 would be an exponent. But exponential is the description. So we could say the company has been suffering exponential losses in the past 2 quarters. Something needs to change. Does that make sense? How we'd use exponential? So it's something that like describes this arc, or the arc the other way. So exponential growth. Hopefully that makes sense to you guys. Does that make sense? Does anybody have any questions about that?
No, it's clear.
Okay. And I think we're good on this page otherwise. Does anybody have any last questions? Okay. Let's try this Audie, and also Audie, welcome to class. Can you read the role of the teacher?
Okay. Teacher, you are collecting math homework. You wonder if the student even knew the topic of the home multiplication, division, etc.
Good. And let's have Alexandra, can you read the role of the student?
Yeah, you don't have your math homework. Make excuses.
And let's start with Audie. How would you start this conversation?
Okay, students. Today's homework is about multiplication. You have to bring it tomorrow morning. I don't know. You have
Okay,
to
so
bring it.
you're collecting the homework.
Okay, you are collecting math homework. Oh, so it is more than one. I don't know. What is that?
So it was the homework that they did last night that is
Oh,
due today. And so it's in class, and yeah, you have to collect it.
oh, okay. Okay. Uh, good morning, good morning, students. Before we start our today's class, I need you to, how do you say, uh, give it the homework me? How do you say?
Uh,
You need to
hand in the
hand
homework.
hand in the homework last night. Okay.
Okay. And Ken, how would you respond? Oh, yeah, let's go with Ken. Ken? Okay, Alexander, how would you respond?
I'm sorry, teacher, but I'm afraid I forgot my homework at home. Can I bring it tomorrow? Because I really did it yesterday, and I'm prepared to answer uh, any questions that you can ask me.
Nice, yeah, I think that's good. And let's have Diana. How'd you respond?
Uh, okay, good answer, but uh, I think it's very important that everybody has the homework here because we are going to practice. So if you can, you can stay with another student and share the answers, the homework.
Okay, interesting. Okay, and Laura, how would you respond?
That will be perfect because I still can remember the solution for the problems due to the fact that I have a good memory.
Check, check, check.
Okay, Ken.
Ah, yes, thank you.
Nice. Okay, perfect. I think that's great. Um, and Mauricio, how would you respond?
If someone has problem, you can make appointment in my office or at my office.
I'm not sure what you mean.
Sorry?
I'm not sure what you mean.
If someone has problem in math to understand the lesson or to understand the homework.
So, if anyone has any problems
Yeah.
about the homework, you can make an appointment in my office. Right? Yeah. I think that's good. Audie, how would you respond as the student?
Okay, teacher, it will be great. Thank you.
Okay. Yeah, I think that's good. I think we're about good here. Does anybody have any questions about this roleplay?
I'm sorry, about making an appointment. Isn't more correct to say arrange? We can arrange.
I think they're both equally accurate. Make an appointment, arrange an appointment. Arrange is maybe a little
Making
bit.
appointments like in a business, commonly or not.
Yeah, but yeah, make an appointment in my office it works for school too.
All right, I was just wondering. I'm sorry.
No, don't be sorry. It's a good question. And any other questions? Okay. And Audie, can you ask Ken the first question?
Hi Ken, how often do you use math in a normal day?
Yes, hello. I rarely do math. Do use do math in everyday life. I just calculate some simple things. Even though I rely on the kind of calculator machine on mobile phone or the computer.
Okay. Yeah, so I rarely do math in everyday life. I just calculate simple things. I even rely on the calculator on my phone or computer. Okay. Yeah, and we already know Alexander uses math a lot. Ken, can you ask Alexander the next question?
Okay, Alexander, are there time when 2 plus 2 equal 5? Explain.
Alexander? All right, Deanna, what about you? Do you think you can answer this one? Deanna, are you there? What about you, Laura?
Can you hear me?
Yep.
It is related to sometimes in life the things. It's like a philosophic answer that we are looking for.
Yeah.
Yes. So it's like say that in life not always the things goes like are supposed to be. I'm not sure.
Okay, so yeah, things don't always go like they should.
Okay.
Maybe. Yeah, Mauricio, do you think you can answer this question?
Which one? The second? No.
Yeah.
I don't know what does mean 2 plus 2 is equal 5. Sorry.
No, it's okay. Adi, do you think?
I haven't heard about this philosophy before, so I have no idea. But I think it is about the um, like in a party or something in the government, or I don't know.
I don't know about that. Ken, do you think you have an answer to this?
No, I'm not good at math, and maybe it's almost like a riddle.
Yeah, it is kind of like a riddle. Yeah, does anybody think they've got like any basic idea of it? Maybe Alexander?
Maybe when some druids are summoning the old spirit of someone.
Yeah, I mean, I think that's kind of part of it. It's thinking about like spirit or supernatural, just when things are more than the sum of their parts. So you're talking about like spirit or faith or something like that. When things are not necessarily countable. or when things seem like they're more than what they really are. Yeah, so it's kind of talking about when 2 plus 2 equals 5, you're talking about something that you can't quite count. But it added together, it makes something more. Yeah. And so, yeah, I guess you kind of either believe that or you think that it's only ever 2 plus 2 equals 4. But, okay, interesting. Alexander, can you ask Laura the next question?
For sure. Do you prefer math or maths?
Well, it's easier say math than maths, so I prefer math.
Yeah.
Okay. Nice. And Andre, welcome to class. Andre, how's it going?
How's it going? I am free time now.
Okay, so you're free?
Yeah. I am teacher maths.
You're a math teacher?
Yes.
Okay, cool.
Cool.
And where are you from, Andre?
I'm from Canada and Quebec.
Okay.
I am French Canadian.
Perfect. All right. Yeah, it's nice to meet you, Andre.
Nice to meet you too.
And one small thing, I'm a math teacher. We would say. So just changing the order around. Does that make sense?
I am a math teacher. I'm maths teacher.
Yeah, I'm a math teacher. And math would be British, if you want to say that.
Okay.
Okay. Does anybody have any questions on this page? Okay. And let's look at this. Laura, can you read the role of Calvin? And Mauricio, can you read the role of Hobbes?
Yes.
So can you start out, Laura?
Okay, I start. You know, I don't think that math is a science. I think it's a religion.
A religion?
Yeah. All these equations are like miracles. You take two numbers and when you add them, they magically become one new number. No one can say now it happened. You either believe it or you don't.
This whole book is full.
Other one, sorry. That's still Laura. Sorry, Mauricio.
Okay.
Oh, sorry.
This whole book is full of things that have to be accepted on faith. It's a religion.
And in the public schools, no less, call a lawyer.
As a math atheist, I should be excused from this.
Okay, good. Can you repeat excused?
Excused.
Excused, yeah. Atheist.
Atheist.
Uh-huh. And then miracle.
Miracle.
Good. Okay. And was there anything else? I think that might have been good. So let's have Ken, what's happening here? What is happening in this comic?
Yeah, I think kind of this boy using his own logic to avoid math, to study math.
Yeah.
Very logical, but in the end he refused to study math. Yeah, for this excuse. Yeah.
Yeah. What do you think about his logic? About, math being kind of like little miracles, things that you can't really prove, things that might not really exist to some extent? What do you think about this logic?
Kind of Uh, I don't know. I'm not good at math because I just know the very pretty basic math only. But usually, basic such math has a clear answer. But sometimes religions kind of religious things doesn't have a clear answer. That's one difference from religion.
Yeah. So I think part of it is like physics and chemistry are provable, and math not really. You can't like do an experiment on it, so it's kind of a little bit like a religion to some extent. I think he's got like a point there. So yeah, maybe Alexander, what do you think about this?
About this comic,
Yeah.
just actually, I didn't understand it at the end, and especially the last part.
Okay. Yeah, I think this is a good point. So, does anybody think they understand the end? To explain it?
Is that he doesn't really understand maths, and for him it's like impossible to understand. That's why he thinks that is something that you have to believe, because he doesn't really understand it. I don't know. Huh?
Yeah, so he's saying that math equals like faith or religion.
Yes.
And in the United States, there is what we call like a separation of church and state. So this means you can't teach religion in a public school, a state-run school. So he's saying because math is like religion, you shouldn't be able to teach math in a public school. Does that make sense?
Yeah,
Yeah.
Yes.
so far I got it.
In a public school. And Hobbes says, call a lawyer. Yeah. Okay, and I think we're good here. Does anybody have any questions or comments here?
Yeah, sometimes to understand a kind of this kind of gag requires a cultural, political, or social kind of knowledge. So I didn't know that kind of thing. So yeah, kind of
Yeah.
yeah.
Yeah, no,
Thanks
it's
for your explanation. Yeah, I could understand it fully. Thank you.
perfect. I'm glad. Yeah, comics are always really tricky to understand because they do have a lot of, social background too, like little weird things in a culture. Andre, as a math teacher, do you have anything to say on this, Andre?
NS,
Yeah, what do you think about this?
I am a teacher physics and chemistry and computer science, computer and math too.
Okay. Yeah.
Yeah.
And so do you have anything to add on this comic before we move on? Do you have anything else to say?
Épouvante?
Yeah, a comment. Okay. Maybe if not, that's fine. Let's go to the next one. Skip that. Let's look at this. And let's have Andre. Can you read the title?
Identify the symbol, tell when it is used.
Yeah. Identify.
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 Yeah, identify.
Identify.
And then the symbol.
And then the symbol. Symbol.
Symbol.
Symbol.
Good. That's how when
Symbol.
it's used.
Okay.
What's the first symbol?
Multiplication.
Yeah. Multiplication.
Multiplication.
Multiplication symbol.
Multiplication.
What's it do?
Equality
Equality?
is a.
Oh, yeah.
Oh,
So
sorry. Okay.
can you make a equation with a multiplication symbol?
By 2x plus from 2x plus 3 equal 7.
Okay.
7.
So this is a little bit more like algebra.
Yeah, it's algebra. You have 2 multiplication x plus 3 equal 7.
We'd say 2 times
2 times. I'm sorry.
x.
Okay,
Plus
2 times
3.
x plus 3 equals 7.
Yeah, and then you just solve for x. So yeah, this is more algebra, but good. I think that's perfect. Really good equation. Diana, what about the next one? What's this sign?
It is a division.
Perfect. And can you make an equation with a division symbol?
Okay. Just an operation could be.
Yeah,
For
an
example,
equation.
10 divided by 2 is 5.
Nice. Perfect. What about this next one, Laura?
I think that I'm going to need help because this is I don't know. I know in Spanish, but in English I don't know.
Vertical. Vertical?
Nope.
Oh.
Starts with an
Maybe
S.
Racine.
Mauricio, do you
Square.
think
Square.
square
Yeah.
Square.
root symbol?
Square root symbol. Okay.
Yeah. Okay. So, Laura, do you think you can make an equation with this?
A square root of 4 is 2.
Nice. Perfect. Really, really good job. Good formation of this. So the square root of 4 is 2. And that's awesome. And Mauricio, what about the next one?
Exponential.
Yeah, so it would be maybe exponential. It's an exponent.
Exponent.
Yeah. And we could also say squared. So this is x squared. 2 is the exponent. Perfect. Mauricio, can you make an equation using an exponent?
Well, I can try. I'm not sure about the sentence, but maybe 5 exponent 2 is 25.
Yeah, so
Is equal.
5 root 2 equals 25. So we could say 5 squared is 25. We could also say 5 to the second power is 25. That's probably the most common way of doing it. So to the second power. So because you can do it any power. So 5 to the 25th power is a really large number. And then you could also say cubed would be to the third power is cubed. But yeah, that was really good, Mauricio. And then this next one, Ken, do you know what this next one is?
F of x.
Yeah.
X function x.
The function of x.
Yeah, it function of x. Yeah, the function of x.
Yeah, and so these are tricky. Does anybody think they can give an example problem of the function of x?
Yes.
Okay, can you, give an example?
The function of x equal x square 2.
X root 2?
Yeah, or x second power
X
2.
to the second power.
Okay, x to the second power plus x plus 3.
Quadratic formula. Okay.
Is equation is parabolic.
Pardon?
Is a parabol.
I'm not sure what you just said.
Is this? No. Damn it.
Sorry?
1 minute. Is parabol.
Parentheses?
Quadratic. Equation quadratic. No?
The quadratic equation?
Yeah. Quadratic equation.
Yeah. Okay. Yeah. So yeah, generally my experience, so f of x, we'd have like, so you use f of x if you're given that, and then you like find something with it. But yeah, that's fine as for the quadratic equation. Anyways, so does anybody have any questions before we move on? Okay, and let's do a little bit of reading. And let's split it up, though. And so let's have Alexander. Can you read the first part?
All right. Clearing all that snow as quickly and cheaply as possible requires choosing the most efficient routes. One with no backtracking or scenic routes. And how to do that? Math writes Marcus Wu in Wired. This is also used to most efficiently deliver mail and pick up trash for city residents.
Nice. Efficiently.
Efficiently.
Mm-hmm. Let's do cheaply.
Cheaply.
And then requires.
Requires.
And choosing.
Choosing.
Backtracking.
Backtracking.
Scenic.
Scenic.
Good. All right. Well done. And Diana, can you read the next part?
Yes. In the 18th century, mathematician Leonhard Euler proved that one could find a route across all the bridges connecting Iceland in Königsberg, just once without doubling back. But his solution required that every intersection consists of an even number of roads. That sure doesn't apply to Boston, where many roads end in a T or suddenly turn one way. So, how to most efficiently blow the over 100 of snow in the city? In the 1962, Chinese mathematicians Mei Kuo Kang introduced the problem in the general case with both even and odd intersections.
Good. Okay, so let's look at. I'm gonna do the pronunciation in the chat box. Mathematician.
Mathematicians,
Mathematician.
mathematician,
Close. In the chat box, can you see that? Mathematician. Mathematician.
mathematician,
And islands.
islands,
Yeah, islands.
islands.
Suddenly.
Suddenly, suddenly,
100 inches.
pardon?
100 inches of snow.
100,
Inches.
100 inches.
Uh-huh. Okay, and maybe Euler. Leonard Euler.
Euler.
Mm-hmm. Okay, and does anybody have any questions so far?
Yes, sir. What does scenic and plow mean?
Scenic?
Yeah.
Okay, so scenic, does anybody know what scenic means? So it's like scenic is having a good view or good scenes. So something that's beautiful would be scenic. And plow, does anybody know what plow means? So it's like pushing something, either snow or earth, so you can plow the land in order to plant things. You can plow the snow in order to be able to drive. Does that make sense?
Mm-hmm.
Okay. And I think we're with Mauricio. Can you read the next part?
Yeah, for sure.
So, sorry, Laura, did you get it skipped? Laura?
You asked, is everything clear? And I answered
Yeah.
in the, that's why.
Was Diana, you read this, right? Yeah, sorry. So let's have Laura. Can you read the next one?
And he called it the Postman problem and proposed a solution. But there are further complications. Priority is given to major arterials. There are multiple snow plots and salt trucks at work, and cities want to avoid having to pay overtime wages to the drivers. But you don't need the perfection solution, just one that gets the job done, concludes Wu. So engineers can break the problem down, for example, by dividing a network of streets into smaller networks that they can tackle individually using the Postman algorithm, for example.
Yeah, good. Let's look at proposed. Proposed.
Proposed.
Um, complications.
Complications.
And priority.
Priority.
Um, arteries.
Arteries.
Having.
Having.
Concludes.
Concludes.
Individually.
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 Good. Okay. Well done. And Mauricio, can you read the next part?
Yeah, for sure. The city of Toronto uses ArcGIS software that incorporates all the variables and automatically spreads out an optimized route, which has saved some money. The Boston Mayor's Office of New Urban Mechanics is using math algorithms and softwares to find the best way to clear the streets of this season's record-breaking snow with inconsistent success.
Good. Inconsistent success. Good. Incorporates.
Incorporates.
Variables.
Variables.
Route.
Route.
Urban.
Sorry. Urban. Urban.
Urban.
Urban.
Mechanics.
Mechanics.
Good. Mechanics. All right. Good. Does anybody have any questions here?
Yes. Okay, for the pronunciation, I don't sure for to pronunciation. You pronounce E or you pronounce pronunciation or you pronounce pronunciation shin with a little I.
Pronunciation.
Shin. It's not shin. Pronunciation.
Pronunciation. And we want to emphasize A. Pronunciation.
Okay, pronunciation.
Sorry, pronunciation.
Pronunciation.
Good. Pronunciation.
Okay.
Yeah.
Is the shin? Shin is not S-E-E-N. Okay, shin.
Shin. Pronunciation.
Pronunciation. Shin.
Mm-hmm.
Okay. Okay, thank you.
You're welcome. And so we are just out of time. Thanks for coming in. I've got another class right after this. If you want to join, I'd love to have you. And see you guys soon.
Thank you. Bye.
Bye.